Okay, today we're going to do an introduction to Chapter 3. Before we can start Chapter 3, we need to do a little review of linear equations and their graphs. Our essential question is, how do you write and graph equations of lines? And this is something that you've done a lot of in Algebra 1 for sure. So probably even a little bit in pre-algebra. So let me just remind you, I'm going to go with one form of the equation of a line. This form is called slope-intercept form, and it is y equals mx plus b. So this is slope-intercept form. And you probably learned a couple of different forms, but we're just going to focus on this one this year, and then next year we'll go over the other forms again. So first of all, m is always our slope. And we know slope is basically the formula for slope is y2 minus y1, or the change in the y, or the change in the x's, x2 minus x1. And b is always our y-intercept. This is the place on the y-axis that the graph crosses. The y-intercept can be written as a coordinate, and the x-coordinate is always 0, and then there's some y-coordinate, which is your b. Okay, so let's do our first example. Oops. We're going to graph y equals 3x minus 2. So I'm going to identify my slope. So first of all, here my slope is, well, 3, or because we always think of slope as rise over run, right? The change in the y over the change in the x. I can rewrite 3 as 3 over 1. And then my y-intercept, let me write that as, yeah, I'll do that. So y-intercept is going to be, well, that's a negative 2. Or in other words, it can be written as 0, negative 2 as a point. Okay, so if I graph this, thinking about my y-intercept first, so I'm always going to start at my y-intercept. So here I'm going to start at 0, negative 2, and then I'll use my slope to get a second point. So I want to make sure I've got space on my graph where I can go down on the y-axis to negative 2. Okay, so I start with my y-intercept at 0, negative 2. And then I use my slope from there. This is a rise of 3 and a run of 1. So that means I'm going to go up 3, which is going to put me up here at positive 1. And then I'm going to run 1, which puts me at the point 1, 1. Now 2 points form a line, so I can now graph that equation. So this is the equation y equals 3x minus 2. Okay, let's see. So next example, I'm going to give you a graph. So example 2. Let's find the equation of the line. All right, so we're going to graph this line. And then we'll find its equation. Having technical difficulties with my pencil. Okay, so this line has, let's see, the point negative 1, 2. Negative 1, 2. And the other point on it that will be given is 3, -1. Okay, so let's find the equation of this line. So we'll start by saying, all right, we know that the equation of a line looks like this, slope-intercept form. Let's find our slope and let's find our y-intercept. Okay, so the first thing we're going to do is find our slope. Well, slope is always rise over run, or in other words, the change in the y's over the change in the x's. Okay, so one thing I can do is I can just count, because these are exact coordinates, right? They're whole numbers, so they're pretty easy to work with. So I can just say, well, my rise, I don't actually rise at all, right? If I'm going from left to right, I drop down 1, 2, 3, which means I go -3. If you think of this like a slope triangle, I go down 3, and from here to here, I run 1, 2, 3, 4 to the right, so it's positive. So your slope, you could think of this as -3/4. The other way of doing it is to just take these 2 points, call one of them x1, y1, one of them x2, y2, and subtract them. So y2 is -1 minus y1, which is 2, all over x2, which is 3, minus x1, which is -1. So you can see here I get -3, minus a negative becomes positive, so -3/4. So either way works. A lot of times if you're not given a graph, you're just given 2 points, you're going to want to use this way. But if you are given the graph, then you might as well just go ahead and count. Okay, so either way my slope is -3/4. Okay, so I'm going to start my equation here. I've got -3/4 for m. Now my graph is not 100% perfect. I have no idea what this actual number is right here. So in order for me to figure that number out, I can use this equation. I can choose one of the 2 points that I have, right? Because these points both have an x and a y. So I can plug one of them in or substitute one of those points in for x and y. And the only unknown then will be b. Okay, so I think what I'll do is I'll go ahead and I'll just use this first point. So I'm going to choose to plug in the point -1, 2. So this could be my x value, this is my y value. I'll plug those in or substitute them in into my equation. So this is really 2 equals, and that's just going to give me +3/4 plus b. Now solving for b, I'll -3/4 from both sides. And so these will cancel out, and I'll be left with what b equals. Well, 2 minus 3/4, you have a couple of ways of thinking about this. Maybe you can do this in your head. You have, $2 and you take away 3/4. Well, then you're left with $1.25. Otherwise, if that's a struggle for you, think of this as 2 over 1. Get common denominators of 4. So this is 8/4 minus 3/4, which is 5/4. And 5/4 becomes 1.25, right? 4 goes into 5 one time with 1 left over. Okay, so now I'll take my b, plug it back into my equation where I was just missing b. So my final equation here is y equals -3/4 x plus 1.25. Now what happens, let's talk about horizontal and vertical lines. So a horizontal line, let's see, let me just draw a coordinate plane here. Okay, so there's my coordinate plane. If I were to draw a horizontal line, well, let's just say it goes through y equals 2. Okay, so I'm going to draw a horizontal line here through y equals 2. Well, guess what? This equation, no matter what x value I put in, my output's always 2. So this equation is y equals 2. So for a horizontal line, if I take any 2 points on this horizontal line, and I try and find the slope of this, okay, so let's just think about the slope here. Is there any rise between these 2 points? Just think about rise over run. Any rise at all? Any change in the y's? There's no change in the y's. There is a run, so here it would be, 2 units. 1, 2. Well, what's 0 divided by 2? In other words, 2 times what will give you 0? Well, that is 0, right? So the slope of a horizontal line is always going to be 0. So the slope is equal to 0. And the equation is always going to look like this. Y equals whatever the y-intercept is. Okay, so that's a horizontal line. Now let's talk about a vertical line. Again, I'm going to draw a coordinate plane here. And this time I think I'll pick x equals 2. So I'll draw a vertical line through x equals 2. Oops, this is x. This was y. Make sure you label your axes, otherwise it gets a little bit confusing. Well, this vertical line right here is x equals 2. Okay, let's talk about its slope. So between any 2 points, I'll choose, how about these 2 points? Here I had a rise of 2. But did I have any run? Is there any change in x values? None whatsoever, right? So let's think about this. 0 will go into 2 how many times? So 0 times what number will give you 2? There is nothing in the world that you can multiply 0 by to get 2. So we end up calling this undefined because it's not possible. Okay, so for a vertical line, the slope will always be undefined because you really can't divide by 0. And the equation of a vertical line will always be x equals whatever the x-intercept is. Yeah, that's a P. So just to summarize, a horizontal line looks like the horizon when you look out at the horizon, and it's always a y equals equation, like this one is y equals 2. A vertical line, okay, this crosses the x-axis, so the equation is always going to be x equals whatever the x-intercept is. For example, this one, the x-intercept is at x equals 2, so the equation is x equals 2. All right, let's try another problem. So let's do a problem. Okay, let's see what was that? Example 1, example 2. Example 3 is graph. We'll do 2 of these just for fun. So how about we'll start with, let's do x equals negative 3. So graphing x equals negative 3. Well, x equals negative 3, you're just going to memorize this. X equals negative 3 is basically everywhere where x equals negative 3. Every single y value corresponds to x, to its input, or its x value being -3. So when I graph this on a coordinate plane, this is going to be a vertical line. The x-intercept is -3, 0. And the line is vertical. It just looks like this. So I'll label my x-axis, my y-axis, and I'll also label my graph. Oops, that's -3, sorry. All right, B. How about we'll do y equals negative. How about y equals -3? I can't get too creative here. All right, so y equals -3 is where every single y value, no matter what the x value, the y value equals -3. So that's a horizontal line. Again, I'll make another coordinate plane. Label my x and my y-axis. So my y-intercept, y equals -3. My y-intercept is at -3. And my line, my equation, or the line of this equation, is the line, the horizontal line that goes through that y-intercept. So this is y equals -3. See the difference? So for this one, no matter what the outputs are, all of my inputs are always -3. So this point is -3, -1. This point is -3, 1. In comparison, for every input that I choose, doesn't matter, x equals 1, x equals 2, all the outputs are always going to be -3. Slope of this one's undefined. Slope of this one is 0. Okay, so you really need to figure out a way to remember this stuff. Okay, let's do another example. How about example 4? Oh, let's see. We're going to write an equation of the line that passes through the point and has the given slope. Through the given point and has the given slope. All right, so the point it passes through is -8, -5, and the slope that we're given is -1/4. Okay, it's a line, so we're going to use a linear equation. So we'll use slope-intercept form. Now I already know my slope. My slope is -1/4. I'm just going to go ahead and plug that in. Notice here I have 3 unknowns. Okay, right now you're not able to solve for 3 unknowns. Maybe if you remember some of your Algebra 1. But for right now, let's just say you can't have 3 unknowns. That's okay, because over here you have an x and a y. I can take that x and y and plug it in here for x and y, and then I'll only have 1 unknown that I can solve for. So this is my x, this is my y. Just plug them in. So -5 equals -1/4 times -8, right? I'm plugging in -8. Well, it's being multiplied to -1/4, so I'm going to make that a fraction. And then I'm going to add b. Okay, so we got -5 equals, well, first of all, a negative times a negative is going to be positive. And this 4 and 8 can both be divided by 4. 4 divided by 4 is 1. 8 divided by 4 is 2. Negative times negative is positive. 1 times 2 is 2. Plus b. Okay, so then I'm going to subtract, let's see, I'm trying to solve for b, so I'm going to subtract 2 from both sides. So b is equal to -7. So now I know my b, so I can basically take this b and just substitute it back in to my equation that I've put the slope in already. So my equation of this line is y equals -1/4 x minus 7. Okay, let's do one more example. So example 5. Okay, so for this one, we're going to find the equation of the line. With the following points. Okay, so the 2 points are 2, 1 and 5, 3. So again, it's a line, so we know that we can write this in slope-intercept form. Okay, so a couple things that I need. The first thing I should always want to find is my slope. Okay, so we're going to find that first. And remember, slope is y2 minus y1 over x2 minus x1. Okay, so this is your first step. Always find this first. Well, in order to do that, I'm going to have to call this, how about my first point? How about my second point? Doesn't matter. You can call the first one your second point. Okay, we're going to plug it into the formula here. So basically, I want my change in my y's, so 3 minus 1, over my change in my x's, or 5 minus 2. This gives me 2 over 3. So I've got a slope of 2/3. So now I'm going to take that 2/3, I'm going to plug it in. Okay, so now I've got y equals 2/3 x plus b. So now the second thing you want to do is you got to solve for b. Okay, so number 1, here, let me write out steps here. Find slope. Step 2, solve for b. And I'm going to use one of these points. It doesn't matter which one you want to use. Just make sure you're consistent. So if you choose to use this point, this is your x, this is your y. So I'm going to plug this point in here for my 2 of my unknowns, and then I'll just have one unknown that I can solve for. So I'll use that point because the numbers are smaller, but you totally would get the same thing if you use this point. This is like 2 over 1. So I get 1 equals, well, that's the same as 4/3 plus b. Subtract 4/3 from both sides. Or subtract 1 1/3 from both sides. Okay, so I get b equals, now some of you might already know what 1 minus 1 1/3 is. And if you don't, no big deal. We'll just subtract fractions. We're going to get common denominators. So common denominator of 3. I'll just write it off here to the side. So this is 3 over 3 minus 4 over 3. As long as I have common denominators, then all I do is subtract the numerators. 3 minus 4 is -1. So this is a -1 over, and the denominator stays the same. So b is -1/3. So I'm going to plug that right back in here. And I'm going to end up with y equals 2/3 x minus 1/3, or plus a -1/3.